Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy for chemistry. This is lecture number 33. In this lecture, I will explain you types of dyne system for calculation of lambda maxima. So let us take the first dyne system, and that is open chain dyne system. It is also known as non-cyclic or acyclic dyne system. So according to Woodward-Fisher's rule, if one or both double bonds are not present, remember this, if they are not present in a cyclic ring, and cyclic ring doesn't mean only 6 member, it can be any number, but both double bonds are not present in one cyclic ring, it is known as open chain or non-cyclic or acyclic conjugated dyne system. For example, CH2 double bond CH, single bond CH, double bond CH2, or it can be written like this also, bond line formula. These two are the same, 1,3-butadiene, or maybe CH2 double bond CH, single bond CH, double bond C, and this carbon may be the part of ring. But here you can see both double bonds are not in cyclic ring, they are open. So this is also example of open chain dyne system. Or if there is cyclic ring, maybe of 6 member, 5 member or whatever, but if one double bond is present in the ring and another double bond is outside the ring and in conjugation, matlab in alternate position, then it is also known as non-cyclic or acyclic conjugated dyne system. And when such system is present, molecule absorb UV visible radiations of definite wavelength. Okay, so this molecule is going to absorb UV radiations of definite wavelength which is known as base value. And base value of open dyne system is 217 nanometer. So this will be given to you when you calculate lambda maxima for given unknown compound. But this is very important that open chain dyne system has base value 217. That means when any molecule has open chain dyne system, this is the minimum wavelength which will be absorbed by the molecule. Okay. Next system, second system is known as Homo annular dyne system. Now, in this type of system, Both double bonds are present in one cyclic ring when both conjugated, that means alternate, double bonds present in one cyclic ring of any number of carbons. It is known as homoannular dyne system. As for example, suppose there is only one single ring of 6 members and these double bonds are in one ring only and they are in alternate positions. That means this become your system. Okay, then it is called homoannular dyne system. Or if two benzene rings, or sorry, two hexagon rings are fused like this. If one double bond is here, another is here, this is also homoannular dyne system because both double bonds are in conjugation and both are present in one ring only. It can be like this also. Suppose one double bond is here, another is here. Now, in the beginning, you feel like this double bond, which is over here, is not in this ring, right side ring, but it is not true. In fact, this is a common wall. This is a common wall, and this is shared by both rings. Suppose we give name to this ring A and B, then this double bond belongs to A ring as well as B ring, and therefore this become your homoannular dyne system. So please remember that this double bond belong to both the rings A and B. Okay, that is why it is called homoannular dyne system. Next example can be like this also. Suppose in this case there are more than two alternate pi bonds or double bonds in different rings. We give the name to these rings A, B and C. Okay, so here we will see that the first double bond and second double bonds are in different rings, but second and third double bonds are in the same ring. So this become homoannular dyne system, and this is very important system. So if this system is present, then we will consider only and only homoannular dyne system, and this system is extended in C ring as well as in A ring. But that is called extension of this dyne system. But basic ring remain or basic system remain homoannular dyne system. Okay, so these are all examples of homoannular dyne system, and base value for homoannular dyne system is 253 nanometer, which will be given to you when you have to calculate numericals. So don't worry, you don't have to remember these values, but you should know that when homoannular dyne system is present, you have to take base value as 253 nanometer. This is minimum. Okay. Now next one is called heteroannular dyne system. So here, when both conjugated double bonds are present in different adjacent cyclic rings of any number of members, it is known as heteroannular dyne system. Examples: suppose two rings are given. One double bond is present in ring A and another double bond is present in ring B, like this. Both are in alternate positions. This becomes your conjugated dyne system. But here this system is called heteroannular dyne system. Why? Because both double bonds are in different adjacent rings. Sorry. It can be like this also. This is also heteroannular dyne system. Starts from here, single bond and then double bond. Okay. Here both double bonds are in different rings. You can see that. If more than two rings are present, like this, then it can be like this also, where double bonds are present in different rings. That is very important, and they should be in alternate position. Then and then we consider this as heteroannular dyne system. For heteroannular dyne system, base value would be 214 nanometer. Sometimes 215 nanometer is also given, but you have to consider whatever is given to you when in exam. Okay, so don't worry, these values will be given to you. You have to just find out which kind of system you are given, and then accordingly you have to substitute the values of base value of different systems. So there are three main conjugated dyne systems. One is open chain, another is homoannular, and the third one is heteroannular dyne system, and each one has different base value. Once we take base value, then we have to add certain wavelength for increments which are present along with this dyne system. There may be more than one double bonds in more than two alternate double bonds. Then we have to add some extra wavelength value for extra double bonds and other things also. I will explain you all these increments in next lecture. Thank you so much.